All right, good morning, everyone. I hope you're all doing okay today. Today, what we're going to keep working on is this idea of taking those flows of interaction that we designed last week and starting to take this idea, break it into different classes at the high level, and then start to implement the functionality that's in this thing. Last class, what I introduced to you was this new idea of layers of responsibility. And so we're trying to take this single responsibility principle that we've been applying to individual classes at this point. So like, I want to make sure that my domain model objects don't do printing. And what we're starting to do is take this single responsibility principle and begin to apply it to like broad classes or broad groups of classes. All of these classes are going to be responsible just for the logic of my application. All of these classes are going to be responsible for just the input and output of my application. And they're going to communicate to each other by calling methods and transferring, using domain model objects as the way that they're communicating with each other. So we're sending domain model objects to this logic layer. The logic layer is making changes to these domain model objects or changing its own internal state and sending those things back to us so that we can present them back to the person that's using our software. I want to keep working on this today. I want to keep going with the Mentimeter that we started on Monday to kind of get through the stuff that we've got for that. And then what I want to do is I want to show you some code that takes the ideas that we've got here and puts it into classes. So I want us to be able to actually see this interaction that is implemented for this flow, the battle flow that we have for Pokemon. And then finally, what I want to do is take a little bit of a look at design by contract. So by the end of today's lecture, what I want you to be able to do is to continue to be able to divide some code from a complex project into higher level modules. And this is focusing on that layers of responsibility idea. And I want you to be able to use preconditions, postconditions, and invariants to validate the runtime behavior. I'm going to strike that last part because that's not really what we're doing today. We're not validating the behavior of an abstract data type, but rather we're validating that the values that are passed to us as input as we start to implement this logic layer of responsibility are in fact valid. And again, valid here for design by contract very much means against dev folk, against the people that are in this room, we're not validating user input by doing this. They will overlap with each other in some cases, but we're not validating user input yet. We will validate user input, but we're not validating user input yet with this idea. So what I quickly want to do is just remind you of these layers of responsibility and what each layer of responsibility is supposed to be responsible for. So to do that, I want to pop open my tablet here. And I've got our diagram that I shared with you in class last time. We are going to start with 2 layers of responsibility. We're going to add to this over time as we get to different parts of the course. But for now, we're focusing on just 2 layers of responsibility. We've got this UI layer, and the UI layer is going to be the code that our person using our software is actually going to directly interact with. So the UI layer will have explicitly the responsibility to print information out to our display, and it will explicitly have the responsibility of getting input from this person. So this is my mom and my dad typing on the keyboards, giving me input. They're reading the messages that I'm printing out. That's what responsibility this class set has, or this layer of responsibility has. You actually kind of started to do this in phase 1 of your project when you started to think about using these separate classes for printing your domain model objects. In this phase and in this kind of layers of responsibility part, we're actually going to take these ideas of input and output and maybe merge them together into a single class for this interaction that we're doing. But the user interface or the UI layer is responsible for printing output, and it's responsible for getting input from the person that's using our software. The classes that are in this layer are the only ones that are responsible for input and output. We're not going to have any input or any output in this logic layer that we've got on the other side. Our UI layer is going to be interacting with classes in our logic layer by calling methods. I want to annotate this, and this is basically calling methods. Our UI layer will know how to interact with the logic layer. It's going to be able to take input that we get from our person using our software, transform those into domain model objects, and it's going to call methods on the logic layer classes that we've got, and it's going to pass to those methods instances of the domain model objects that we've created as a part of our class diagram. Our logic layer then has this responsibility to encode application logic. So it's going to make changes to the domain model objects that are passed to it. It's going to make changes to its own internal state that it's using to keep track of what's going on in this application. And it will eventually return either domain model instances back to this UI layer. So I've taken input, I'm calling methods on the logic layer does whatever it needs to do. It sends these things back to the UI layer, and the UI layer then has the responsibility of reporting these changes to the person that's using our software. So it will do system.out.println, it will add things to the windows that we've got. It's going to have this responsibility of showing the person using our software that these changes have been made. All right, are we all okay with this idea? Okay, I'm going to show you classes. I will show you actual code that does this to really drive home this point. But abstractly, we've got a set of classes that are responsible for input and output, transforming text into domain model objects. We've got a set of classes that are responsible for encoding application logic. They do not do any input. They do not do any output. Okay, awesome. So I'm going to pop back over here. And what I want to keep doing here is I want to keep doing this Mentimeter that we had from last class. So I'll hold this up for a couple of seconds if you want to join in, and then we'll keep working on classifying code. I'll start by summarizing the ones that we did last class just to get you back into this mindset of what we're doing. But then I'm going to keep asking you these questions. So I'll hold this for 5 more seconds, and then I'll switch to Mentimeter. All right, I'm going to pop over to Mentimeter now. So I'm going to summarize the things that we already answered questions about here. So the first thing that we were focusing on was this idea of the battle screen itself. This was our starting subtask when we did the battle. The first question that I asked you was, which layer of responsibility does this battle screen belong in? And the best answer here to me is that there's actually some stuff in the battle screen that belongs in both the UI and the logic layer. But I wanted you to pick UI here at the beginning, and I was delighted to see that you were all picking UI here. The battle screen is kind of like we've got to initialize some state. Our battle has some state. Our battle has some information about it that it needs to keep track of itself that doesn't really have anything to do with printing output or getting input from the user. But there's lots of stuff as part of starting up a battle that definitely has printing output and getting input from the user. The next question then was, which part of battle screen belongs in this UI layer? And lots of people were picking this getting input. So choosing between things like item, fight, Pokemon, or run. And I was really delighted to see that. The other thing that does appear here in this battle screen set up starting subtask is that we're actually going to have to ask this logic layer to initialize itself. We're going to have to tell the logic layer, you need to start setting yourself up and start setting your own internal state up so that the UI class that I'm making here can begin to interact with you. So there's a little bit of this that is in the UI layer, and then initializing this battle logic layer classes in this UI layer as well. Now we've got what part of this battle screen belongs in the logic layer, and the part that belongs in the logic layer, like I've been saying here, is we got to start making sure that the state is set up for this battle. So the state that it's in right now is going to be in progress or ended. There's a little bit more to the state that I want to be able to model, but for the purposes of us talking about this in a quiz format, that's the sort of thing that we're doing and keeping track of our currently selected Pokemon. The logic layer, I want to point at this one because it kind of shows up here a little bit more. The logic layer here itself, in terms of the battle screen, it's not really going to be responsible for making instances of input, item, and fight. And I'm being a little pedantic here, but these item and fight, these are menu options that we might be seeing in our UI layer, but there is no domain model object that represents fight. There's no domain model object that represents the selection item. Yes, we have items in our domain model, but there's nothing that represents the selection item here. So we're not going to be making instances of input from that part. What we then proceeded with here was taking a look at the move selection screen. And so with the move selection screen, we've got one input that's being provided by that subtask, and that is the selected move itself. We've got this do attack process. This is something that's happening in our this is something that's happening in the system itself with no user input, but it does provide some output. And the output that we can see here is that there is no PP left, and there's other kinds of outputs that come from this do attack option. The layer of responsibility that the fight option belongs in, coming out of the battle screen here, is the UI layer, because we're not really doing anything with application logic. All we've done to go from the starting subtask to this fight selection or this move selection screen is we picked the fight option. So we're moving from one location to the next here, and this belongs purely in the UI layer. We're not doing anything with changing the state of the battle itself. Nobody's attacked anybody else yet. All we've done is selected this option so that we can select from more things here. The move selection screen, so once we get to that point, this is where we're basically saying, here are the moves that you can choose from. Please choose one. This also lives entirely in the UI layer. There's nothing here that's changing the state of the battle at this point. We're just making choices about what to display to the person that's using our software. All right, before we ask more questions, do you have any questions for me about the state that we're in right now? I don't know about all of you, but I am looking forward to a long weekend. Yes. Is it a long weekend? Yes. Oh, I am so happy to be the messenger here. Yeah, it is a long weekend. Yes, yes. Yeah, it is a long weekend. I'm really happy. I'm really happy that I could be the person to share that with you. Yes. Okay. Awesome. Okay. So let's ask some more questions about this. Let's continue to ask some questions about the state of where these different things belong based on the flow of interaction that we've got here. As I said last time, I turned off this fastest answer thing first, and I welcome you to talk to each other about the decision that you're making here. Okay, awesome. I'm really, really happy to see this, yes. So move selection is this thing that shows up. I've tapped on fight, and now I'm prompted with a list of moves that I can choose from for this specific Pokemon that I'm battling with right now. There are several choices here that I think are the right choice. The first one, lots of people are picking here, which is great. Prompting for input. Which move? Which of these moves do you want to select? And even more minimally, just which move. I'm not telling you which moves there are, just tell me a move, and hopefully this is something that your Pokemon has. Prompting for which move. Producing output, yes. This is where we're also going to be responsible for printing, possibly, the list of these moves that we can choose from here. One person picked this, and I'm going to give big thumbs up to that person. Transforming the word tackle into a move, into a domain model object. We're getting this input. We're using scanner. My mom is typing in the word tackle. I need to take that and transform that into a domain model object. I'll come to you in just a second. I need to take that and transform that into a domain model object so that I can ask somebody else to do this thing for me. Constructing instances of the Pokemon, nobody picked this, and that's fair, that's good, because it's not really the responsibility of this part of the UI layer to make these Pokemon for me. It might be the responsibility of some other UI class to do this. It might be the responsibility of the UI class that is... I'm actually trying to think about gameplay where you would do this with the UI. And it might be something like you're doing the trade operation between two different Game Boys. This is where you'd be choosing which Pokemon that you have to be able to do that transformation. The other places where I'm thinking about this are like wild Pokemon, and that would be more like the system is just making a Pokemon for you and telling you this is the one that you've encountered. So it's not really the UI layer. I'm going to come to you in just a second. I'm going to go to you first.
I would have thought that like a tackle would already have been created as part of a Pokemon. Like if a Pokemon has a set of moves, you're just choosing the move, and now it's already there. Now you just tell that that's the move that you're using.
So, no, you are right. I'm going to try to summarize what you just said to make sure that it's captured on audio, but also just to make sure I understand your question. The point that you're making is that the Pokemon as a domain model instance already has moves in it. And that's true. The Pokemon does already have moves in it. It does have instances. The part that we're trying to do here is like when this program is running, the way that you're going to interact with it is using your keyboard. And you're going to type in the word tackle. And I need to kind of go through those domain model objects that are attached to my Pokemon and figure out which one of those things is tackle. This is the transformation that's taking place here. So I'm not necessarily making new instances of this. And I realize I may have misled you by putting the words new tackle in there. Forgive me if I've done that. But this might also be just pulling from an existing domain model object instance that we've got, yes. So thank you for asking that question, and I hope that clarifies. Yeah. Yeah. Yes, so like if we did do the Pokemon, the PKMN flow through this subtask of battle screen to choose here are the Pokemon that you have. And I think in that case, it would be similar to what the question is being asked over here is we're just going to choose from existing instances, but it's still the transformation of Pikachu into an instance of Pokemon. Yeah, yeah. Okay, awesome. I can't remember if we actually saw a leaderboard last time. And removing the fastest option first really wrecks this, I think, because now everybody's at the top. Okay, so now we're going to be thinking about, we've moved past the selection of move, and now what we're starting to think about is the do attack processing subtask or processing step here. Remember that a processing subtask is something that our system is doing. This is software that's doing it. We're not really doing much user interaction or any user interaction as part of this. And there are different outputs that are provided by this. So in this case, we've got 3 different options. We've got that our enemy did or did not faint, and that we have no PP left from the move that was provided to this thing. This one has a short amount of time, but I welcome you to talk about it still. Okay, awesome. Yes, so I want to say that generally, I don't want to say that this is a universal truth. I don't want to be stuck with that. I want to say that generally, our diamond-shaped processing subtasks or sub-items, they are logic layer things. They are almost always going to be logic layer things because this is something that the system is doing without any input other than what's been provided by the previous subtasks. Here's our next question. Yeah, awesome. Okay, so we are now going from this processing part, our diamond here, that is definitely 100% in the logic layer. And now we're starting to show that something has happened. Now we're actually starting to think about outputs provided by this thing. And outputs that are provided by this processing thing are something that we've got to communicate to the person that's using our software. When we need to communicate something to the person that's using our software, we need to move back into this UI layer of responsibility. Some of this stuff still does belong in the logic layer because different things are going to happen based on the outcome here. This thing fainted or did not faint is something we have to communicate back to the person that's using our software, but then stuff proceeds after this. There's other stuff that's happening after this. And so there's some things that do belong in a logic layer after that. Yeah.
So those outputs generated by this processing step are not considered part of the do attack. So like I thought do attack would be part of partially logic and UI because it has those outputs that need to be provided to the user back. So, but we actually don't consider it as part of the show.
The outputs that are provided by these processing tasks are things that we often want to communicate. The idea of conducting the attack is something that I want to make sure is contained entirely in the logic layer. And part of my rationale for this is that when I switch from using a text-based UI into a graphical UI, I don't want to have to re-implement parts of the attack process in my graphics UI. I really just want to be able to call this logic layer method to do all that stuff and get what I need as the output from that thing so that I can present it in different ways to the people that are using software. So the attack itself should belong entirely in the logic layer for that reason. The outputs of this can be communicated back to that UI layer so that we can actually show these things on the screen, but the attack itself should be done entirely within the logic layer. Does that make sense? Okay, awesome. Okay. Got 2 more questions for you about this. Okay, good. Yes, I'm really, really delighted to see this. Lots of people are picking on only printing out. Our UI layer is only responsible for printing output and getting input. It's not really going to have any responsibility to do any of the logic related to this attack thing. I'm going to come to you in just a second. It shouldn't be responsible to do the move to see if it makes the enemy faint. It shouldn't be responsible for asking the question, has the enemy fainted? The logic layer should communicate back to the UI layer that the enemy has fainted or has not fainted. It shouldn't be responsible for switching players unless there is some complex mechanism that's involved in like players choosing who gets to go next. But in the case of this Pokemon thing that we're working with, player switching just happens as a result of this is the end of this person's turn. So we're going to switch players and this is happening in our logic layer. Collecting money and experience here. This is something, again, that's still part of the logic layer. I want to report that this much money and experience has been collected. I do want to print that out, but it's not the actual act of collecting money or experience that I want to put into my UI layer part. Yeah.
So would the like the logic part of this done in the do attack diamond, and then it would either go two ways based on that, it would change the path and then turns out what it should be.
Effectively, yes. So the whole do attack thing is in that diamond shape, and then there's going to be different outcomes that come from that. The outputs may be interpreted by the UI, and we'll talk next week a little bit about how we can start to do that, different kinds of outputs being produced by this thing. But for now, it's just this thing happened. It's been communicated back to the UI part. Yeah.
Is that like our UI and our logic pretty much just the same as like the packages that we would have in our in like for example our project or is it like a higher level of file structure over top of this package?
So the question is about using packages for implementation, and it is packages. So we're going to use packages to do logical and physical separation of these different layers of responsibility that we have. And so when I show you my example, I have a UI package and I have a logic package and I have classes that are responsible for all of this stuff kind of spread across those two different places. Yeah. Yeah.
Bring it back to the Pokemon example. Would that supersede your item structure that you have currently? Like you have your domain, you have your Pokemon, you have your item, that would supersede?
It would be alongside the domain model package that I've got. So I'm going to have a domain model package because I want to make sure that the things that are being used to communicate between these two layers, they are their own thing. This is its own kind of like sub part of my software. I'm going to have a logic layer package and a UI package. And internally, they are going to be responsible for creating instances of the domain model objects, passing them back and forth to each other. So we're not annihilating the domain model stuff. We're keeping that domain model stuff around because that's going to be effectively the way that these different things are communicating with each other. Yeah. Does it make sense? Okay, awesome. All right. Here's our very last question about this battle flow. Okay, awesome. Our logic layer does not print anything. A massive red flag of logic layer classes is the words system.out.print whatever. That does not belong in our logic layer classes. We can have, for us, dev folk, system.err.print something, but my parents are never going to see that. I don't want my mom and dad to see things that I'm printing out to myself as information for development purposes. System.out does not belong in my logic layer at all. I don't want to do any printing. I don't want to use scanner to get any input in my logic layer classes. All of the other things that we've got here, collecting experience and money, doing the attack to see if the enemy is fainted, those are all things that are responsibilities of the logic layer. It's a tie. Okay. Okay, I'm going to stop this because that's too much. I will share with you this Mentimeter on the course webpage after today's class. I've begun to summarize some of the things that I've said verbally to you in class about the initial parts of this in the slides. I may update the slides afterwards to reflect the remaining things that we've got here. But I'm not going to step through these right now because we kind of already done that together. So what I want to do now is I want to actually take a look at some code. I feel like you're starting to get the hang of how do each of these different things and the flow start to get put into these different layers of responsibility. But how do I actually take these layers of responsibility and start making some code that represents these different things that we've got here? And so what I want to start taking a look at here is my implementation of this. This is in that 2450 Amon Git repository. I've linked to this on the course webpage if you want to follow along in your web browser. If you want to follow along in IntelliJ and you've got this already on your machines, this is where you would do this git pull operation to get the most recent changes that I pushed up into that. What I want us to take a look at here is how we have physically organized these files. So I want to take a look at how these layers of responsibility are physically organized in packages. So to the questions that were being asked here before. And I want to be able to look at the logical separation of these classes. So how have these different classes been created such that they represent the different parts of my domain model flow, or my flow of interaction. So I'm going to pop over here to IntelliJ here. And I think I'm going to make this slightly bigger. And then I'm just going to ask at the back, is this big enough for you to see okay? Okay, awesome. So I want to start here with actually my main method. So what I've got is, this is the main class that's kind of created alongside of IntelliJ when all of this starts. And what I'm doing in my main method here is I'm doing some initial setup. I would expect that a lot of this initial setup would happen in some other class at some other time as part of like beginning the game and that sort of thing. But for the sake of beginning to do the battle flow here, what I've got is a private static method here that has the responsibility effectively of having a hard-coded set of trainers and Pokemon and moves and stuff. So I'm doing all the setup here just so that we have some domain model object instances to begin to work with here. And so this is going to be a battle that's happening between me with Squirtle and Gary with a Bulbasaur. Once I've got this stuff set up, what I'm then going to start doing is taking a look at the classes themselves that are implementing the different parts of this flow of interaction. And so I have two different packages that I've implemented. I'm going to pull this over to the side here. I'm going to hide my domain model objects. So my domain package still exists. This is still something I want to have here. I don't want to remove these domain model objects because these are how the different layers of responsibility are going to communicate with each other. I've got two different packages here. One of them is called logic and the other one is called UI. This is where I'm going to be putting the two layers of responsibility that I've got here. When you're implementing this for your project, you're going to have many classes in each of these packages. But for us right now, we're just doing one flow of interaction for this example. So we have only one class in each of these things. Yeah. So if it's both UI and logic, I'm actually going to step through the example here to kind of show you what I mean by that. But it's going to be put into two different classes still. So the parts that were UI and logic in the battle screen, like the initial starting subtask that we had, this is stuff that's going to happen effectively in the constructor of the UI that's going to create instances of the logic layer class for us. So there are some things that are kind of split between these two layers, but they're coordinating with each other to make sure that both of those things are happening. Yeah. Yeah. I would say one class. Oh gosh, I got to repeat that to make sure that I got you. One class per package per flow of interaction. That would be a reasonable rule of thumb, but I don't want to say like that it has to be exactly that way. Yes. So in this case, we have one flow of interaction that is battle, and it has one class in each of the two packages that we've got here. Yes. Yeah. Okay. So our setup here is that I've got this battle display class. The battle display class is going to be the one that is responsible for doing all input and output for this flow of interaction. This class does not really have any internal state. The only thing that this class has as internal state is an instance of the logic layer of responsibility class for this flow of interaction. And this is where we have the UI plus logic part here. Our UI layer right now is responsible for creating an instance of the logic layer class that it's going to use. So in our initial setup part, this is where we have that overlap of responsibilities between these two classes. The only other kind of state that this class has in it is an instance of scanner, its ability to get input from the person that is interacting with this software. It doesn't have any other internal state at the class level. It doesn't need to keep track of anything because the logic layer is effectively responsible for all of that stuff for us. When I create an instance of my logic layer class, I'm going to pop that up here, and I'm actually going to start putting them kind of side by side. My logic layer class here, when I initialize it, has some responsibility to start establishing the state of the battle itself. So taking what we have in the battle and starting to put that into the state that it is maintaining. The state that my logic layer class is maintaining is that there are different trainers that are part of this battle. The trainers have Pokemon. There are currently selected Pokemon. The battle has a state. It's either continuing to happen or it's over. And it's going to keep track of what the current player is. So whose turn it is right now in this system. This class has a post condition, and the post condition is a class invariant. This is not a domain model class, but there are still valid states for this thing to be in, and I still want to encode that. Like, for example, at the very bottom here, the only time that my battle should be ended is if one of the two players that I've got have all of their Pokemon fainted. That's the only situation that we should have an ended battle here. And so I want to make sure that I'm sticking to that internally as part of my implementation of this logic layer class. So the setup here, once we finish this constructor, the setup here is effectively done. So I've got this new instance of my battle display. My battle display has the responsibility of asking the logic layer to establish itself, set up its own internal state, and then we're returning back to our main method. Once we go back to our main method here, what we're doing is now we're going to ask that display class to start doing the battle. I want to start working with the flow of interaction that I've got here. So that takes us back to battle display here. The start battle interaction is going to be responsible for printing information out to the person that's using my software. So printing out that we're having this battle between these two players, and it's always going to be asking the logic layer, what is your current state? I could keep these trainers in this class, but I want to minimize the amount of state that my display class has for itself. I want to let the battle be responsible for telling me about all this stuff. I want to ask questions about its state from the UI class so that I can get that information from it and then display it to the people that are using my software. This one does have the responsibility of basically making sure that it keeps going while the battle is in progress. There's a tiny little bit of logic it has to know. It must know this to be able to do this thing. But it effectively then proceeds. I'm going to ask for the tasks that we could get back from this. The battle screen actions prompt is something that's going to print out. What do you want to do here? Fight, item, Pokemon, or run. We get this back. We have this switch statement that's going to decide what that is. I've only implemented fight here, so the only thing that we could possibly do is fight. When we go down to fight here, this is where we're starting to do things like printing out summaries of what the Pokemon are. And here is where I'm doing some delegation. I'm asking this other printer class that I've created here to do the printing for us. And then I have a move selection screen. My move selection screen is then going to print some output. And it's going to take that output and it's going to transform the input that's provided by my person using my software. Going to print out this list of moves, and then it's going to take the input that I get from them, and it's going to transform that into a domain model object that I return back to my fight so that I can do the move itself. The move itself is where we're going to actually ask this domain model object or this logic layer class to do the attack for us. So I printed output, I've got input, I've transformed that to domain model objects. I'm asking this logic layer class now to do this thing for me. Once we're in this domain model object here, now we're starting to do the attack, and this is going to take a lot of the stuff that we've got in that processing step and encode it here. So the logic of doing things like switching players when it's appropriate, ending the battle, and that sort of thing. Yeah.
Yeah. So should the move selection string be a separate class if it was a separate subtask in our flow diagram?
So that's a good question. The question is, should the move selection be a separate class? It can be. You could have that move selection be a separate class in your UI layer of responsibility if you want to. But as far as I'm concerned, it's also fine to have that be a method in this one class. At least in the context of what we're doing here, it's quite short. And so there's not too much to worry about in terms of having a separate class. Yeah. All right. So when I hit play on this, I've added this little bit of, I don't know, I'm delighted by this stuff. I've added this. This is a dependency that I've added to my Maven POM file. You're welcome to use this as well if you want. It's called jfiglets, and it just takes a string and it gives you a nice big string so you can print out stuff like this. And what we get from here is this flow of interaction that we're able to not fight, I can tackle, I can fight, I can tackle. And it just kind of switches back and forth between the two players, fight, tackle. This is a really boring. Someone fainted, the battle is now over. I don't know, I'm quite happy with that. I'm quite happy with that. So we've taken this flow of interaction, we've separated these different things into layers of responsibility, and now we've got some code that represents this, this flow of interaction that we've got here. All right. The very last thing I want to talk to you about today, before we head off, is I want to talk to you about a little bit more related to design by contract. We've only got a few minutes left, but I actually think this only really needs a few minutes of time. This is not something that is earth-shatteringly different about what we've already been doing with design by contract stuff with class invariants. So far, all we really know about is class invariants for design by contract. And we have been applying those class invariants as preconditions and postconditions to the state that we have for our domain model objects. But not all preconditions and postconditions are class invariants. We can have preconditions and postconditions that are separate from class invariants. This can be things like inputs that are being provided to methods themselves. We want to make sure that we're guarding against those things. And we want to make sure that those arguments are valid, where valid here is generally going to be things like not null and not negative. So the kinds of things that you've already been putting into class invariants, but they're not tied to class instances anymore. These are just being inputs that are provided to us. We also want to make sure that the outputs that we're providing as part of this are going to be valid as well. This doesn't necessarily just mean return values, but this might also mean side effects that should have happened in the context of the method that we're looking at. Something must have changed as a result of what we're doing. Generally, the idea here is if you give me valid input and I'm in a valid state, then I promise to give you valid output and maintain this idea that I still am in a valid state by the time you get control back from the method that I'm doing right now. So I want to quickly take this time to apply a couple of preconditions and postconditions to this example. But again, this is not earth-shattering stuff. This is very, very similar to the stuff that you've already seen with class invariants. So I'm going to pop back to IntelliJ here. And what I want to focus on here, in fact, is the doAttack method. So one of the preconditions that we've got right now as part of this the battle itself has a class invariant. I want to make sure that I am still valid in terms of me being a battle. So I want to make sure that the state that I've got is valid for things like all Pokemon are fainted for one of my players. But another precondition for this method is that we have an input. We have an input. And so if we have an input then that means that we should also make sure that what has been provided to us is also a valid input. That doesn't really have anything to do with the state of the battle. It's just something that's been given to us. And so I want to add to this preconditions.check not null, attack with must not be null. I'm not guarding against my parents here. They do not have a null key on their keyboard. I want to make sure that whatever has been passed to me by the person calling me is not null. It's something that I can actually work with once I get past this point. Another precondition here can be something like the selected move must be a move the current Pokemon can do. I'll come to you in just a second. When I'm being prompted with moves, I'm going to make a selection from something, and I want to make sure that by the time it's getting to me when I'm trying to do this attack, that the Pokemon that should be doing this move can actually do the move that I'm asking it to do. Yeah.
If in the attack we have something that guarantees it will never be null, we still need to check that attack with is not null? Because this is a class instance in Java, it can be null. There's not really a way for you to forbid that this method. Sorry, any instance of the class, though. Like we have.
What we're trying to prevent against here is I don't want to be able to do this. .do attack. I don't want to be able to hard code the word null into this. I want to forbid that from happening. I also want to forbid this from happening unintentionally. If I have a variable which with attack like this, and with attack happens to be null, I want to forbid that from happening. I want to stop that situation from happening. Yeah. I want to make sure that the current Pokemon can actually do the move that I've got. Yeah.
Yeah, so my question is about the output that is generated after the process step.
Yeah.
Should, like, for example, after the battle ends and one of the players wins, so should the logic return a string, like the name of the player, or should it return, like, the instance, like the trainer itself, so that, like, we use the class and not a string?
So that's a good question. The question is effectively what should happen in terms of the battle is over here. What should we be returning? And the question is asking, should we be returning a string or should we be returning the trainer that has won? That kind of depends. That kind of depends on what you want to be able to accomplish. It might not even be either of those things. If you want to be able to, for example, report that Pikachu got 15 points of experience and you got $30, I don't know what that unit is in Pokemoney, but 30 things, that might be a different domain model object that you're constructing in the logic layer and then returning to the UI layer to be able to report that complex information about the interaction that you've just had. Yeah. Okay. I'm not going to code this part up, but the very last thing I want to be able to say here is that when I'm doing this do attack, I want to make sure that the attack that was used was actually used by the code that I've written here to do the attack. And so that's going to be one of the post conditions that I have here. My post conditions are that the battle is still valid. So the state of the battle is still what I am expecting it to be. But I also want to make sure that the move passed to me has actually been used. Assuming that it was a valid move that was passed to me, then what I'm expecting to be able to ask about this is, has the PP of this move been reduced by 1 because I've actually used this move to cause my enemy to faint or not faint? The way that I'm going to accomplish that is effectively to say something like int starting PP is equal to attack with dot PP. This is the current state that I've got. And I'm going to use the word precondition here. This is overloaded, unfortunately for us. But what I'm going to say here is preconditions dot check state
I want to say that starting PP is equal to move dot attack width dot PP minus 1. I want to make this assertion. I want to make sure that the move has actually been used by the code that I've written here. What you'll find if you run this is that I haven't actually done that. I haven't actually done that. And I've commented this out here kind of on purpose, but I haven't actually done that. All right. OK, so at this point, what you should be able to do is divide a complex project, these flows of interaction, into higher level modules. So separating code into layers of responsibility at appropriate interfaces. And you should continue to be able to use preconditions and postconditions. But now you should be able to start thinking about these in terms of the methods that are being invoked, the inputs that are being provided by the methods, the side effects that are being applied by the methods, and the return values that are being applied by the methods. That's it for today. I hope you all have a great rest of your day, and I'll see you in